Okay, dear students, all of you know we are discussing the problem based on increasing and decreasing function. Very important application of the derivative. Okay, and here a function is given. We have to find out the intervals. A function is given. We have to find out the intervals in which interval the function is strictly increasing and the function is strictly decreasing. Understand? Let's see. So a function is given fx is equal to x square plus 2x minus 5. Let us find out slope of the function f dash x by finding the derivative of the function. So derivative of fx is equal to x square, derivative is 2x plus 2. Understand or not? Okay, now you have to equate the derivative 2x plus f dash x must be equal to 0. Let us equate f dash x to 0. Then 2x is equal to how much? Minus 2. Okay, then x is equal to minus 1. X is equal to minus 1. Here the point, the domain, you see here the real number x is equal to minus 1 divides the real number line, divides the real number line into two disjoint intervals, okay, two disjoint interval. Is it clear? Now you see here, this is the real number line and this is the value is 1 minus 1. This is divided into interval into two disjoint set, two disjoint interval. One is minus 1 minus infinitive, another is minus 1 infinitive. Yes or no? Okay, two intervals. One is minus infinitive minus 1 and another one what? Minus infinitive and infinitive. Two intervals we are getting. So this real number line is divided by x is equal to minus 1 into two disjoint interval. So in the interval, now when the domain of the function lies between the interval minus into minus 1. Let us see. Okay, minus, it means suppose you are taking minus 2, suppose. Let's see, x value is minus 2. Let us take any values in the interval minus infinity to minus 1. Okay, understand? You will see then what is the slope of the function? Slope of the function what? If you are putting the values x is equal to minus 2, it will be minus 2, this will be minus 4 plus 2, which is minus 2 is less than 0. And we know that since the slope of the function is less than 0, the function is what kind of function? Strictly decreasing function. Yes or no? Hence, the f is strictly decreasing. If the slope of the function less than 0, then the function f is strictly decreasing function in the interval minus infinity to minus 1. Very simple. Yes or no? Similarly, when x lies in the interval minus 1 and minus infinity, then f dash x, so minus infinity minus 1, we can take the values, we can take any value more than minus 1. Suppose I can take 2, suppose x value 2, or I can take x value any value, take any particular domain, x is equal to 5. If I take x is equal to 5, then f dash x is equal to 5 to the 10, which is positive value and greater than 0. Okay, since the slope of the function is positive, that implies f is strictly increasing. F is strictly increasing in the interval minus 1 infinitive. Understand or not? Thus, the function is strictly increasing in the interval minus infinitive to minus 1 and strictly decreasing. The function is strictly decreasing in the interval, not increasing in the interval, because you see f dash x less than 0. So in the interval, the function is strictly decreasing minus infinity to minus 1 and here the function is strictly increasing in the interval, okay, minus 1 to infinity. Okay, this is how you can find out a function in which interval the function is strictly increasing and the function is strictly decreasing. Okay, understand? Okay, let us see and let's follow. So dear students, in this class I am discussing the problem based on the increasing and decreasing function, okay, based on the concept of application of derivative, okay, from your NCERT book, Standard 12 Mathematics. Here I am discussing question number 6, second bit, okay, exercise 6.2. Okay, in the previous class we already discussed exercise 6.2, question number 6 first bit. Here question number 6 second bit I am discussing. In this question, okay, it is given that we have to find the intervals in which the function is strictly increasing and intervals in which the function is strictly decreasing function. Okay, in which intervals the function is strictly increasing, in which intervals the function is strictly decreasing in the set of real number. Okay, understand? The function is given here. Here the function fx is equal to 10 minus 6x minus 2x square is given. Understand? So to find out the increasing and decreasing function, we have to find out the derivative. Okay, so derivative of the function f dash x is equal to, okay, it will be minus x minus 4x. Understand? Now let us equate the derivative of the function to 0. Now f dash x is equal to 0. Let us equate f dash x is equal to 0. That implies minus 6 minus 4x is equal to 0. That implies 4x is equal to here minus 6. Understand? And x is equal to minus 6 upon 4 or minus 3 upon 2. Understand? Here the domain, here the real number x is minus 3 by 2. Divide the real number line. So here you divide the real number line into two design set. Here is minus 3 upon 2. Okay, divide the real number line into two design set. What is one interval is two design interval. One is minus infinity minus 3 by 2. Another is minus 3 by 2 infinity. Understand or not? So in the interval minus infinity minus 3 upon 2 and minus 3 by 2 infinity. Understand? Okay, we are getting two design interval, and in this interval we have to find in which interval the function is strictly increasing or in which interval function is strictly decreasing. Understand or not? Okay, so when you say when x belongs to minus infinity minus 3 upon 2 in this interval, okay, let us say number, suppose I will take a number, it is minus suppose 7 upon 2 I will take, okay, which number lies between minus 3 by 2 and minus infinity. So let x is equal to minus 7 upon 2. Suppose let x is equal to minus 7 upon 2. Understand? Then what is putting the value in the derivative of the function f dash x? Okay, we shall get the slope of the function. Okay, minus 6 minus 4 into minus 7 upon 2. And you see minus 6 minus minus, you see is equal to 14 and it is 8. Though is greater than 0, that implies the slope of the function f dash x is greater than 0. So if the slope of the function is greater than 0, according to the definition, okay, the function is strictly increasing function. Hence the function f is strictly increasing. Hence function is strictly, yes or no, increasing in the interval minus infinity and minus 3 upon 2. Understand? Is it clear? First one you got. Okay. Similarly, when the coming to the next interval, when the x lies in the interval minus 3 by 2 to infinity. Okay, let's see. Okay, now let's see x is equal to minus, let in the interval when x belongs to minus 3 by 2 infinity. Okay, let's take a value it is suppose x is equal to, we can take the number lies between minus 3y to infinity. It means this value can be taken also. Suppose I can take 3. Suppose 3. Okay. And then what is the value of f dash x? So f dash x is equal to minus 6 minus 4 into 3. And this is minus 6 minus 12 minus 18. This is minus 18. And less than 0. That implies f dash x is less than 0. It means the slope of the function is less than 0. Since the slope of the function is less than 0, okay, understand? Since in the interval f dash x is less than 0, hence the function is strictly decreasing, okay, strictly decreasing in the interval what? Minus 3y to infinity. Understand? Thus we got the f is strictly, thus we got f is, hence f is strictly, so in this interval the function is what? Strictly increasing, and in the interval function is what? In the interval function decreasing. Understand or not? So the function is strictly increasing. Which interval? In which interval? Minus infinity to minus 3 upon 2, and strictly decreasing, and strictly decreasing in the interval minus 3y to infinity. Okay, understood? So this is how you have to find out. And the intervals in which intervals the function can be strictly increasing and the function can be strictly decreasing. Okay, understood? Just to follow it. Thank you. Students, in this problem I am discussing question number 6, third bit. Okay, based on the concept of increasing and decreasing function of your NCERT book, standard 12 mathematics. Okay, exercise 6.2, based on the concept of application of derivative. Okay, and here a function is given. We have to find out in which interval the function is strictly increasing and in which interval the function is strictly decreasing. Okay, here is the function is given that the function is that fx is equal to minus 2x cube minus 9x square minus 12x plus 1. Understand? So before finding the increasing and decreasing function, you have to find out the slope. Okay, so by finding their derivatives, yes or no? So f dash x is equal to, it will be minus 6x square, and it is minus 18x minus 12, right? So this is equal to minus 6 being a common, x square plus 3x plus 2 and minus 6 whole into, it will be x plus 1 and x plus 2. After finding the you see after factorization we will get. Okay, f dash x is equal to minus 6 whole into x plus 1 whole into x plus 2. Now equate the derivative of the function is equal to 0, and understand? Okay, and this is a point where the function is divided into different intervals. In order to find the different intervals, let us equate the derivative of the function f dash x is equal to 0. Then x plus 1 whole into x plus 2 is equal to 0. Understand? Then after that x will be minus 1 and minus 2. Now the real number minus 1 and minus 2 divides the real number line. Let us draw a number line, students. So this number is minus 1 and minus 2, and this is what? Minus infinity and plus infinity. Yes or no? So the real number x is equal to minus 1 and minus 2 divides the real number line into 3 division interval. One is minus infinity minus 2, another is minus 2 minus 1, and third interval is minus 1 infinity. Yes or no? Yes or no? In the interval, this is the interval 1, first interval, and second interval, and third interval. Okay, so here we got I1. Here I1 interval, first interval is what? Minus infinity minus 2, and second interval I2 minus 2 minus 1, understand, and third interval minus 1 infinity. Let's see in this interval, in which interval the function is strictly increasing or strictly decreasing. Okay, so when you see when x belongs to the first interval minus infinity minus 2, okay, let's suppose a number, let us take minus 2 minus 3, let's take a number that is, suppose I will take minus 3, suppose take. So let's x is equal to minus 3, let x is equal to minus 3, let x is equal to minus 3. If I am taking x is equal to minus 3, putting the value, and the slope of the function will be what? This sign is negative sign, you see, and here this sign will be minus 3 plus 2, it will be also negative sign. Yes or no? Okay, here you see, if you put x is equal to minus 3 plus 1 is minus 2, negative, and here minus 3 plus 2 is also negative. So what are you getting here? What are you getting here? So this overall sign will be negative, hence the function is less than, f dash x is less than 0, thus f is strictly, if the slope of the function is less than 0, yes or no, the function is decreasing function, hence f is strictly decreasing in the interval, minus infinity to minus 2. Is it clear? Now let's the second interval. In the second interval, you see when x belongs to minus 2 to minus 1. Okay, suppose this value, let us take a value. So this value in this interval function is strictly decreasing. Let us write first interval. Let us take a value. This is minus 2 minus 1. You take minus 3 upon 2. Suppose take minus 3 upon 2. Yes or no? This value is minus 3 upon 2. Let us take. Okay, so let x is equal to minus 3 upon 2. In this interval, what happened? Let's see. Okay, and you see minus 3 upon 2, you can write also minus 1.5. Then you see the f dash x, put the values in the derivative of the function. This sign is negative. Here minus factor is first, minus is a factor. Here minus 1.5 means this factor is also negative, minus 1.5, and here minus 1.5, this factor will be positive. So the overall sign will be positive. It means the function is f dash x is greater than 0. That's why, since hence the f is strictly increasing in the interval minus 2 minus 1. Is it clear? So this function here in the second interval I2, the function is strictly increasing. Is it clear? Now let us the third interval. In the third interval, when the domain of the function lies between minus 1 infinity. Okay, minus 1 infinity means we can take, suppose the value will be, suppose this value, suppose 7. Let us take 7. Okay, now you are getting now f dash x. F dash x means, you see, now f dash x is equal to minus 6 whole into x plus 1 whole into x plus 2. Here minus sign, negative. Again 7 plus 1 is also, 7 plus 1 is positive, and here 7 plus 2 is positive. It means overall sign is negative. Negative means less than 0. Since f dash x less than 0, so f is strictly decreasing in the interval minus 1 infinity. Is it clear? So here the function is strictly what? Decreasing. Understand? Thus we get in the interval, here you get, what you get? In the first interval the function is strictly decreasing. In the second interval the function is strictly increasing, and in third interval the function is strictly decreasing. Understand or not? Okay, is it clear? So this is how you can find out whether the function is strictly increasing and in which interval it is increasing, in which interval is strictly decreasing. Understand? Okay, by finding the derivative. So important parts of derivative you can understood. Okay, the derivative is an important application to find whether the function is increasing or decreasing, and also is an important part of calculus. Okay, so thank you. So dear students, all of you know we are discussing class 12 mathematics of your NCERT book. Okay, we are discussing exercise 6.2. Okay, and based on the function of increasing and decreasing function, in this class I am explaining question number 7 of exercise 6.2. Okay, take care and look at the question, try to understand the question. Okay, and here the question is given that so that y is equal to log whole into 1 plus x minus 2x divided by 2 plus x. Okay, and x is greater than minus 1 is an increasing function of x throughout its domain. It means we have to prove that the function is an increasing function. The function is an increasing function when x is greater than minus 1. Okay, x is greater than minus 1. Okay, and every domain of the function when x is greater than minus 1, the function is increasing function. Okay, so it means here if you see the number line, this is suppose minus 1 and this increasing function is increasing. The function is increasing function. In the interval what? Minus 1 infinitive. It means we have to prove that the function is increasing function in the interval minus 1 to infinitive. Okay. Here y is equal to, the function is given fx is equal to log whole into 1 plus x minus 2x divided by 2 plus x. Yes or no? So you know, before you have to find out the increasing and decreasing function, we have to find out the slope by finding their derivative. Right? Okay. Let's find the derivative of the function, which is f dash x is equal to, and derivative log 1 plus x is what? 1 divided by 1 plus x into, and 1 plus x derivative is 1 minus 2. Now see x divided by 2 plus x. Now you have to find out the derivative of u by v. Formula you apply here. Derivative of u into v minus u into derivative of v dash v divided by v square. Derivative of u into v minus u into derivative of v divided by v square. Okay. So here derivative of x is 1 into product of the second function 1 whole into 2 plus x. Understand? Minus x into derivative of second function 2 plus x is also 1 divided by 2 plus x whole square. Understand? Okay. So f dash x is equal to 1 divided by 1 plus x minus 2. Let us simplify here. 2 plus x minus x divided by 2 plus x whole square. Understand? Okay, so plus x minus x we can cancel. Plus x minus x we can cancel. Then f dash x is equal to 1 divided by 1 plus x minus, you see now, 2 to the 4 divided by 2 plus x whole square. 2 plus x whole square. Now let us take the derivative. Let us take simplified by taking the LCM. You have to take. You take the LCM. Now it is 1 plus x whole into 2 plus x whole square, the LCM. And here it will be 2 plus x whole square minus 4 whole into, it will be 1 plus x. Understand? Okay. And f dash x is equal to, you see, 2 plus x whole square, you can write 4 plus x square on expanding plus 4x minus 4 minus 4x, and here 1 plus x whole into 2 plus x whole square. First of all, find the derivative. You see now, plus 4x minus 4x will be cancelled, plus 4 minus 4 will be cancelled. So it will be x square divided by 1 plus x whole into 2 plus x whole square. 2 plus x whole square. Understand or not? Okay. Is it clear? Understand? Yes. So we know that the function to be increasing function. If the function to be increasing function, okay, what happened? F dash x must be greater than 0. Must be greater than 0, right? And you clearly see it is whole square is there. 1 plus x whole square. You see now these factors you see. Here x square Here, you see now, since this factor x square divided by 2 plus x square is always greater than 0, this part, because the power of 2 is even. Here 2 plus x square, here power is also even, so the value is always greater than 0. That implies 1 divided by 1 plus x is greater than 0, Understand or not? Yes or no? That implies 1 plus x is greater than 0, and that implies x is greater than minus 1. Okay, so let us take a value. In this value, take x is equal to, suppose any real number you take, suppose x is equal to 3 you take. If x is equal to 3 you are taking, let us check. If x is equal to 3, understand or not? Now f dash x, look at here, x square, this value will be positive, this value will be positive, and this value is positive, so greater than 0. Also you see, understand or not? Thus f is, the function f is increasing function, we can say increasing function in the interval at x is greater than minus 1 or in the interval minus 1 infinitive. This is how we have proof. Thus the function is increasing function in the interval minus 1 infinitive. Is it clear, all of you? Okay, understand? Okay, thank you. So hello students, and here I am discussing question number 8 of exercise 6.2 of your standard 12 mathematics. Okay, and we are discussing the concept on increasing and decreasing function based on the application of derivative. Okay, question number 8 I am discussing, and here the question is given that, here the question is, let me read the question. Find the value of x to which y is equal to x whole into x minus 2 whole square is an increasing function. We have to find the value of x, means we have to find a particular domain. In which domain the function is increasing function, we have to only check that. Understand? Okay, the question is saying we have to find out the value of x, means in which particular domain, okay, the function is an increasing function. Okay, so here is function y is equal to, let us write x whole into x minus 2 whole square. Write question correctly, properly. Then it will be x square whole into x minus 2 whole square. Understand? So fx, y is equal to fx, we can write also x square, and it will be x square minus 4x plus 4. Understand? Or fx is equal to x to the power 4 minus 4x cube plus 4x square. Understand? Okay, is it clear? So now you have to find out the slope of the function, by finding the derivative. Okay, and it will be derivative of x to the power 4 is 4x cube, okay, it will be 12x square plus 8x, all of you know. So that is equal to 4x can be taken as common, and it will be x square minus 3x, and it is what? Plus 2. Okay, and after factorization you will get, here it will be x minus 1 and x minus 2 you will get after factorization. So f dash x is equal to, so derivative of the function we got 4x whole into x minus 1 whole into x minus 2. Now we have to find out you have to equate the derivative of the function f dash x is equal to 0, at which the function is the interval, the domain is divided into design interval. We have to find out the interval, so we have to equate the function f dash x to 0, and after that you see x is equal to 1. After finding here x is equal to 1 and x is equal to 2. Okay, understand? Now let us draw a real number line draw. You see here x is equal to 1, here x is equal to 2, here x is equal to minus infinitive, and x is equal to 0, and here x is equal to infinitive. Understand? So you clear now, you see, and here here the x is equal to 1 and 2 divides the real number line, the real number line into decision interval. How many interval? One interval 1 is, I can write also, and this is what? Interval I1. First interval is what? Minus infinity 0. Second one 0, 1. Another is 1, 2 and 2 infinity. 1, 2, 3, 4. Okay. So we are getting the different intervals into intervals. Intervals minus infinity 0. Another interval is 0, 1. Next is 1, 2 interval, and last interval 2 infinity. So in this interval you have to see, and you see interval value of x, the function is an increasing function. You see in the interval minus infinity of 0, if you put any value of, okay, suppose I am taking any number minus 1, suppose I will take any numbers, this number I will take, any number I will take. Okay, suppose x is equal to, suppose I will take minus 1. Look at here. If you put this interval f dash x what? F dash x. Here fx, x minus 1 and x minus 2. Suppose I am taking x is less than 0, any number, it is minus, this value will be negative. And here also this value is negative. And also minus 1, minus 2, this value is negative. So it whole value will be negative. It means less than 0. So the function is decreasing in the interval. What? In the interval minus infinity 0. Understand or not? It means f is decreasing. Is it clear? In the interval. Which interval? Minus infinity 0. Understand? Point 1 we got. Similarly, in the interval 0, 1. In the second interval 0, 1, if you will take 0, 1, then 0, 1 means one value take 0.5 you can take. You can take 0.5. Let us take a number 0.5. And putting these values, and this value will be what? 0.5, it will be positive. This value will be positive. And here 0.5 minus 1 also what? Negative. Again 0.5 minus 2 will be negative. Only you have to know. Then this whole overall it will be positive, means greater than 0. It means the f is an increasing function. F is an increasing function in the interval 1, 0. In the interval 0, 1, not 1, 0, 0, 1. This is the second point we got. Understand or not? So what we got here? The first point we got, the function is decreasing. Here the function is increasing. Now the interval 1 to 2, when in the interval 1 to 2, you see now here f dash x. Suppose I am taking 1.5. Suppose I will take the value, let us take 1.5. If I will take 1.5, then this x value will be positive. Here 1.5 minus 1 also positive. And here 1.5 minus 1 will be negative. It means the value is becoming negative, which is less than 0. Hence, f is decreasing in the interval. Which interval? 1, 2. This is the another point we got. Third point. Is it clear? So here the function is what? Decreasing function, 1 to 2 interval. Is it clear? Let's see. Okay. Understand? Now see in the interval 2 to infinity. In the interval, this interval 2 to infinity interval. Let us write. In the interval. Now in the interval 2 to infinity. What is that? Suppose I will take x is equal to 3. x is equal to, I will take 3. If x is equal to 3, suppose I will take x is equal to 3, then let's see a certain domain x is equal to 3, then f dash x, you see this will be what? Positive. This also positive, this also positive. So overall value will be positive and greater than 0. Thus we got the interval. Look at here. Hence f is increasing in the interval to infinity. So understand? So here the function is increasing. So you have to find out, our question is asking, find the interval of x which the function y fx is equal to x value and x minus 2 whole square is an increasing function. So you see in the interval 0 to 1, the function is increasing function. Another 1 to infinity, function is increasing function. It means, hence we got, when, understand, when, but in the interval you can write also, okay, understand, in the interval 0 1 and 2 infinity, the function is increasing. The given function f is increasing function. Understand or not? Is it clear? It means, and it is axing 0 to 1 means what? Here you see 0 is less than x. 0 to 1 interval. Open interval 0 to 1 means what? 0 is less than x is less than 1. So value must be 0. Value of x, when the value of x will lies between 0 and 1, the function is increasing function. Between 0 and 1, all the domain of the function lies between 0 and 1, the function is increasing. Again function is 2 infinity means what? What is the meaning that? It means 2 is less than x is less than infinity. That implies x is greater than 2. X is greater than 2. It means when x is greater than 2, whatever the domain value x greater than 2, the function is also increasing function. Understand? So this is what we get. We need to find out, okay, the value of x. It means in which interval the function is increasing function. Okay, understand? Okay, watch it. Thank you. Okay, dear students, all of you know we are discussing the NCERT problem, okay, from your NCERT book, exercise 6.2, based on the concept of increasing and decreasing function. Here is the question number 9 I am going to discuss, okay, and in this question it is given that, okay, let's see the question here in front of you, and prove that y is equal to f theta 4 sin theta by 2 cos theta 2 plus cos theta minus theta is an increasing function of theta in the closed interval 0 to pi by 2. Once again, prove that y is equal to 4 sin theta by 2 plus cos theta minus theta is an increasing function of theta in the closed interval 0 to pi by 2. Okay, so here the function is y is equal to what? Given 4 sin theta divided by 2 plus cos theta minus theta. Okay, let us find out slope of the line. So you have to find the derivative, that is known as f dash theta. You have to find out. So here derivative of 4 sin theta by 2 plus cos theta. Here you see, okay, derivative of sin theta is cos theta whole into 2 plus cos theta. Okay, derivative of u by v minus sin theta into derivative of 2 plus cos theta. Here derivative of 2 is 0 and derivative of cos theta is what? Minus sin theta whole divided by 2 plus cos theta whole square. Understand? And minus 1. Minus derivative of theta is 1. Okay? Understand? Now let's see. That is equal to, we will simplify this one. 2 plus cos theta whole square. Okay? You see 4 whole into 2 cos theta plus cos square theta minus and plus sin square theta minus 2 whole into minus 2 plus cos theta whole square. If you take the LCM, it will be like that. Understand or not? Okay. So that is equal to, look at carefully, this is the LCM 2 plus cos theta whole square. So you see here, understand? So you see now 4 cos 2 cos theta. Okay, you can multiply 4 also. You can multiply 4 here. Okay, let us see the 4 whole into 2 plus cos theta. Okay, cos 2 cos theta, it will be what? 8. It will be 8 cos theta. Yes or no? 8 cos theta. Again, you see cos square theta here, 4 cos square theta. Multiply 4 cos square theta. Okay, and here you see, similarly minus and minus plus sin square theta. 4 here you can write 4 sin square theta. You write here 4 sin square theta. Is it clear? Understand? Once again say cos theta into 2, 2 cos theta, 2 into 4, 8 cos theta. Again cos theta into cos theta, cos square theta, 4 multiplied, 4 cos square theta. Again minus and minus plus sin square theta, 4 into sin square theta, 4 sin square theta. Minus 2 plus whole into 2 plus cos theta whole square. Now you see 8 cos theta plus 4 cos square theta plus 4 cos square theta plus 4 sin theta value we can write here 4. We can write 4 minus, here you see 2 cos theta whole square, it will be what? 4 plus cos square theta plus 4 cos theta. Yes or no? And it will be 2 plus cos theta whole square. Understand? Is it clear? Now you see, again you remove the bracket, simplify. See 8 cos theta plus 4 minus 4, then minus cos square theta minus 4 cos theta, and it's equal to 2 plus cos theta whole square. Yes or no? Is it clear? Now 4 plus 4 minus 4 cancel. So 8 cos theta minus 4 cos theta, it will be what? It will be what? 8 cos theta minus 4 cos theta will be 4 cos theta minus cos square theta whole divided by 2 plus cos theta whole square. Is it clear? Understand? Then that's equal to, you see cos theta you can bring common, cos theta whole into 4 minus cos theta divided by 2 plus cos theta whole square. Is it clear? So this is the, we got f dash theta finally is equal to cos theta whole into 4 minus cos theta divided by 2 plus cos theta whole square. Understand? Okay. And we have to prove that the function is increasing function in the closed interval 0 to pi by 2, so that in order to prove the function is an increasing function in the closed interval 0 to pi by 2, so that what will happen? The slope of the function must be greater than 0. Yes or no? So that, you see carefully, you see in the closed interval 0 to pi by 2, since in the interval 0 to pi by 2, all of you know cos theta what? Greater than 0. Yes or no? Is positive. Understand? In the first quadrant cos theta is positive. Similarly 4 minus, you see again, okay, 2 plus cos theta whole square is also greater than 0, because the power is even number, so 2 plus cos theta whole square is also positive. Understand? You see cos theta, we know in the first quadrant the value of cos theta is always less than equal to 1. Whatever the values of theta, the cos theta always value less than equal to 1. It means the 4 minus cos theta must be greater than 0. Understand? Okay, that implies clearly prove that you say the cos theta is positive in the interval 0 to pi by 2. Similarly, 2 plus cos theta whole square is also positive because the power is even number. Okay, whatever the value of theta, the power is always positive. Understand? And again, since cos theta is less than equal to 1, so 4 minus cos theta always supposed to be greater than equal to 0. That's still positive, and it is clearly proved that f dash theta is greater than 0. Hence, f is increasing function increasing in the closed interval 0 to pi by 2. Is it clear? Is it clear? Okay, understand? So this is how we get the function is increasing function in the given closed interval 0 to pi by 2. Okay, thank you. Let us see and practice it. Okay. Dear students, I am discussing an important problem, an interesting problem, okay, based on the function of increasing and decreasing function of your NCERT mathematics book, class 12 math, okay, exercise 6.2, okay, one of the important concept and property also you can say, okay, it is that, and we have to prove that the logarithmic function is strictly increasing on the interval 0 to infinity. So you have to prove that the logarithmic function is strictly increasing on the interval 0 to infinity. Okay. We can say also this is also one of the important properties of the increasing function. Understand? A logarithmic function is strictly increasing on the interval 0 to infinity. Understand? Okay. Okay. Logarithmic function means let the function fx is equal to log x. Logarithmic function log x. And we have to prove that fx is strictly what? Increasing on the interval 0 to infinity. Understand? Now let us find out the slope of the function by finding the derivative, which is 1 by x. 1 by x. Since in the interval, since x belongs to 0 to infinity, that implies x is greater than 0. So that implies 1 by x also greater than 0. That implies f dash x is greater than 0. Understand? And since the slope of the function is greater than 0, so that implies, hence we can write, hence we can prove it, the f is strictly increasing function okay. So f is strictly increasing function on the interval 0 to infinity. Is it clear? Thus, it is proved that what to prove? The logarithmic function, the log x is strictly increasing in the interval 0 to infinity. Okay, understand? And this is also one of the important properties of the increasing function. Understand? And the logarithmic function is increasing in the interval 0 to infinity. Okay, understand? Thank you. So dear students, in this class I am going to discuss question number 11 of exercise 6.2 of your NCERT book, class 12 mathematics. Okay, and we are discussing the problem based on increasing and decreasing function, okay, based on the concept of application of derivative. Okay, and here is a question in front of you. The question is that prove that the function f is given by fx is equal to x square minus x plus 1 is neither strictly increasing nor strictly decreasing in the on minus 1 1, right? Understand? Okay, is it clear? See now here. So the function f is, let's given fx is a given function, x square minus x plus 1. Understand? We have to find out and this function is neither strictly increasing nor strictly decreasing in the interval, open interval minus 1 to 1, right? Understand? Here the open interval is given, this is minus 1 and this is 1. In this interval the function is neither increasing nor decreasing. Let's see. Let us find out the derivative of the function f dash x, which is the slope of the function, okay, and it is 2x minus 1. Understand? So 2x minus 1 must be equal to 0, equate f dash x, that implies x is equal to 1 upon 2. It means the point x is equal to 1 upon 2, the value is coming 1 upon 2, okay, divides the interval minus 1 1 into two disjoint intervals one interval is minus 1 1 by 2 and another interval 1 by 2 to 1. Okay, so when in this two interval we have to check whether the function is increasing and decreasing. Okay, when x belongs to minus 1 1 by 2, it means minus 1 1 by 2 means what? Let us take a value minus 1 1 by 2. I can take a value, let x is equal to 0, suppose. Let x is equal to 0. If x is equal to 0, then what will happen? F dash x, the value of f dash x will be what? 2x minus 1 is minus 1, less than 0. It means the f is strictly decreasing in the interval minus 1 1 by 2. Is it clear? Understand? Let us take any value in the interval minus 1 to 1 by 2. Let 0 lies between minus 1 1 by 2. Now put the values of 0, okay, in the given f dash x in the slope of the function, and 2 into minus 1 is, okay, becomes negative. It means slope of the function is negative. If the slope is negative, what happens? The function is decreasing function. All of you know. Yes or no? Understand? Is it clear? Similarly, come to the next interval. Is it clear? So similarly, in the interval when x belongs to 1 by 2 and 1, then let x is equal to, let us take a value, x is equal to what? 1 by 2 and 1. What is the value we can take? Can you take now? Let us take a value 1 by 2. The number lies between 1 by 2 and 1. This is, I can take, suppose 3 by 4. 3 by 4 I can take. Yes or no? Understand? 1 by 2 and 1. This number lies between 1 by 2 and 1. The rational number between 1 by 2 and 1. We know what is the rational number lies 1 by 2 whole into a plus b. Yes or no? So 1 by 2 plus 1 is what? 1 by 2 into 1. 1 plus 1 by 2 is 3 by 2. So it is 3 by 4. So number 3 by 4 lies between 1 by 2 and 1. Understand or not? Okay. So let the number 3 by 4 lies between, in this interval, let x is equal to 3 upon 4. If x is equal to 3 upon 4, let f dash x, putting the value here 3 by 4, and it is given that 2 into x minus 1, 2 into 3 by 4 minus 1, and that is what? 3 by 2 minus 1, and which is 1 by 2 is also greater than 0, here greater than 0. It means f dash x is greater than 0, hence that implies f is increasing, strictly increasing. F is strictly increasing. Understand? In the interval 1 by 2 and 1. Understand or not? Okay. So see, the function is, you see in the interval 0 to 1 by 2, 0 minus 1 to 1 by 2, the function is what? Strictly decreasing. and in the interval 1/2 to 1 the function is strictly increasing. It means it is clear that the function is neither increasing, strictly increasing, or decreasing in the interval. Thus it is clear that hence f is neither strictly increasing nor strictly decreasing in the interval -1 and 1. Understand? Okay. Thus it is proved that function is neither strictly increasing nor strictly decreasing in the interval -1 to 1. Okay. Understand? Is it clear? Okay, let us see and follow also and practice also similar type of problem. I hope you are able to understand how to find out, how to check whether the function is increasing or decreasing function using the concept of application of derivative. Okay, understand? Thank you for your interest and keep on watching. Thank you.